everyone, welcome to a video of solving problems from motion in a plane. So this is a question. A body is projected horizontally with a speed of 5 meters per second from the height h. It takes 8 seconds to reach the ground. The time it takes to cover the first fourth of a height. So let us draw a rough sketch of the problem. So there is a body which is at a height h. So suppose this is the h height. This is the height from the ground. The body is at h height. Now this body is projected at a horizontal speed of 5 meter per second. So the speed is how much? 5 meter per second. With this speed, this body is projected or thrown, you can say. So this will follow a path like this. This body will follow a path like this. But finally, it will reach the ground here. And when it reaches the ground, the total time it takes is 8 seconds. The total time it takes is 8 seconds. Okay. So we have to find what is the time. What is the time that it will cover one uh, first fourth of the height. Suppose if I divide the height by 4 parts, 1, suppose 2, 3, 4. Okay. So what is the time when the body will be at this position? What is the time here? In this position, what is the time? They're asking this question. Okay. So in a whenever there is a problem of motion in 2D, we have to convert it into a problem of 1D or linear problem. So how to do this? So this body, you can say this motion is a sum of two motions. One is on this direction, one is on x direction. One motion is on this direction, x direction, and another motion is on y direction. Because the ball, when it reaches the ground, it is moving downwards as well as forwards. It is moving forwards as well as downwards. So the ball is moving in two ways. So I am dividing the motion of the ball into two components. So this component we can say x component, or this component we can say y component. Okay. Now this whole problem is based on the y component of the motion, y component of the ball. Okay. So let us redraw the problem. So ball is here. There is a motion. There is an initial velocity of 5 meter per second, but this is in the x component. So what is the component? What is the component of velocity in downwards direction? There is no component, so 0. Initial velocity is 0. U is 0. Initial velocity is 0. So the ball dropped from the height h and took the time is equal to 8 seconds to reach the ground. This is the problem actually. So from this information, can we find the value of h? Yes. How? H is equal to what? Because we know gravity is acting as in this direction. G is equal to what? Let us say 10 for simplicity of the problem, or you can say to find these answers, you need to take G is equal to 10. Okay. So since the direction of motion and acceleration is in the same direction, the equation of motion will be what? H is equal to ut plus half gt square. Okay. So here h is what? H only, u is 0, so the whole term will be 0 plus half g is 10, and the time it takes is 8. So it's so if I solve this, h is equal to half into 10 into 64. So 1s are 32. So the answer is 320 meter. So the total height of the ball is h. The ball was projected at a speed of 5 meter per second horizontally from a height of 320 meter. Now, what is 1/4 of 320? H by 4 is 320 by 4 is equal to how much? 80. Now the question is, when the ball drops to 80 meter, when the ball drops to 80 meter here, This is 80 meter. What is the time required? In this question also u is 0. Okay. So let us find the time from this information. I am going to use the same equation. Now h is 80. 80 is equal to what? Half of, because u is 0, so I can directly write half of g is what? 10. T square. T square we do not know. So this is equal to what? 80 into 2 divided by 10 is equal to t square. So 0 is cancelled. So t square is equal to what? 16. So t is what? 4. So the time required to cover 1/4 of the distance is 4 seconds. This is the answer. I hope you have understood the problem, understood the solution. And if you have any doubt, you can comment it on the comment section. And if you like this video, share it with your friends and subscribe to my channel.